Thank you for the intro. So we're going to give the talk together. I'm doing also a bit kind of intro to the topic, and then Michael will present you, the other Michael will present you most part of the presentation and the deep dive basically into the container security. So our talk is about, do component reduction strategies fix your container security nightmares? Because no doubt, if you worked with containers before, you probably have some security nightmares around it, at least if you took a deeper look at containers. Let's quickly start with an introduction. Michael, do you want to?
Yeah, sure. So my name is Michael, and I'm working at Securo Consulting for DevSecOps and automation of security assurance. Before I went to security, I was working as a software engineer for many years. And also there I was focusing on automation for quality assurance. So yeah, makes sense that and it was nice for me to switch to the security AppSec area.
Okay, my name is also Michael Helwig. I'm more on the side of strategic consulting around building secure software development lifecycles, DevSecOps area, interested in all things security. And I founded this small consulting company, that logo which you see at the top, Securo. Okay, let's deep dive into it. So first we're going to talk a bit about what is the container security challenge, what challenges do containers bring if you use them in terms of security. Then we will deep dive into one solution strategy maybe for many of those challenges, which is component reduction methods. And this is basically where Michael will also take over and talk about the distroless concept. We will see a quick demo on how the distroless can help you to avoid certain exploitation possibilities. Then we will go a bit into the research in this area, what has been researched there on the market and papers and so on, and arrive at a quick conclusion. So, what are security challenges with containers? We often come into companies, do a bit of consulting, and we find out, okay, they are using containers, but they do not really have a strategy for it. Yeah, there is no real processes for the usage of containers. So that means there is a lack of transparency into vulnerability scanning, into vulnerabilities within those containers. There is no scanning, or there is some scans, but no one looks at them. There are also no trusted repositories. That means there is no limit on the base images that companies use. You do not know where containers originate from, where base images are pulled from. No control, no limit, so a lot of security headaches. At the same time, containers are everywhere, so even your cloud services may run on containers. You get containers from third-party vendors as a delivery, as software deliveries for commercial off-the-shelf applications. So basically, there's a lot of places in your organizations where containers may already be in use, but you are not really aware of it potentially. At the same time, with containers, there comes a bit of responsibility shift, because containers now suddenly lead to developers taking over a larger part of the product stack. They suddenly have OS libraries, OS parts that they are responsible for, and they are not used to that. Let's say it like this. Yeah? So they are not necessarily aware of it. They build the application, they put it in a container, they ship it, everything seems fine. But they are not necessarily aware of all the baggage, of all the overload that they have in that container. And one common reaction that we also experience, unfortunately, when talking to developers, then is a reaction, it's not our code. Yeah? So we do the application, we just put it in a container, but the rest is not our problem. We are not responsible for the vulnerabilities inside the container. But Ops is also not responsible, so who is in the end? You do have complex attack surfaces with containers. We will not deep dive into this, but just thinking about it, you have the application layer, you have OS layers, you have configuration issues, potential network communication, container networks that might be interesting, and you have hypervisor attacks. So you do add a lot of complexity when using containers. And another thing is, the more different base images, the more containers you use, the more headaches you will have in the future, because security is something that does not stay constant. Security degrades over time. There will always be new vulnerabilities, new issues appearing, and the more diverse your container landscape is, the more headaches you will have in the future to keep all that under control. If you look at statistics about vulnerabilities, this report is not from us, it's from a vendor called Sysdig, but we found it very interesting. You see that 87% of images have high or critical vulnerabilities. 30% just have low, medium, or no vulnerabilities. So there is a large number of images out there. I'm not 100% sure how many they scanned. I read in the report the number was at least 25,000, but there are also other numbers, so maybe check out the report yourself if you're interested. And 87% have higher critical images, vulnerabilities, and only a small number of those vulnerabilities is actually exploitable. So they said like 2% is actually exploitable. Of course, you don't know which ones those are. So what does it help you to know that it's only 2% if it's inside your containers? But the other interesting statistics was that there actually is a patch available for many of those fixes and for many of those issues. That means 71% are patchable. It's just not applied in the base images. So the base images are not up to date. But only 15% of those vulnerabilities are actually in use, of the affected components are actually in use from the application at runtime. That means you have a lot of stuff in those container images that is not used, but that contains vulnerabilities. So what do you do about it as a security team? It's quite straightforward. You look at the OWASP design principles, for example, and you find, hey, the more software I have, the more complex my landscape is, the more vulnerabilities I will have. So I'm looking into minimizing my attack surface. And this is basically one of the strategies that we also explored in our company to bring to our customers to tell them, okay, what can we actually do to minimize the attack surface on containers and to make sure that there is not so much overhead for applications that is not needed, but just introduces headaches for the security team. Okay, and that's it. And now I'm handing over to Michael to show us basically how that can be done.
Yeah, thanks, Michael. So I want to start with the sentence, it's secure because it's running in a container. So we get that sentence a lot. It seems like still that misconception that if you throw something in a container, and maybe it's kind of true because processes are isolated from each other and you have that Linux kernel features making up that concept of a container, but still there is something running inside the container. And I really love that illustration of it. So just as an intro to tell you, there's still a lot of things can go wrong. And also we get another sentence from stakeholders, especially stating that teams are not allowed to select any base image they want. But I want to compare it with open source components, and the image illustrates, for example, maybe you heard about Log4j, was a critical vulnerability in a Java open source library supporting logging. And in the end, hackers don't care which path they take to exploit your application. And that's why we compare it with open source components. So teams are allowed to select any base image they want, and that's why you're responsible for the security and of your selected base images. And this is why it's important that we scan them. I guess you all know security scanners, container scanners are scanner tools who statically scan your images for known vulnerabilities. They also find stuff like secrets or credentials lying around in the container. And they are very easy to integrate into CI/CD pipelines, so you can easily set up something like not allowed, that developers are not allowed to merge a pull request if there are security findings, because everyone is talking about shifting left and automating security assurance. And at this point, a little story from our experience working, consulting in a centralized product security team. So imagine a lot of more and more companies are moving to the cloud. We're talking about cloud native, and then they have like 10 or 15 years old legacy Java applications should now get containerized, right? And you have these management policies dictating that they are not allowed to deploy to production if there are critical or high severity findings. And then imagine us coming and scanning these applications 10 years old, and they have like 200 findings, only critical and high severity, which is often in our experience that WTF moment for the teams coming to us, like, hey, security team, first, we want to deploy in 2 weeks. And second, it's not our, like Michael said, it's not our responsibility and not our code. So this is one of the reasons why we came to all these component reduction methods, as we call it. And what it is basically a tool, like tools who minimize the components lying around in your container with the goal of minimizing the attack surface and the noise of container scanners. And there are 4 important tools available, which I'm going to present now. So first we have Google Distoless. It's an open source project by Google, and they made the buzzword Distoless, I guess some of you have heard about it, famous already 2007. And they're providing some production-ready images for certain runtimes like Java, Node.js, Python, Go. And they're very small in size compared to regular container images. Like the static image is just only 2 megabytes, which is also a nice side advantage. Then we have Red Hat UBI Micro, based on the Red Hat Universal Base Images. And the nice thing here is that they don't provide so many prod-ready images you have to build yourself for certain runtimes, but you get the same Linux security hardening and response team as you get with any Red Hat Enterprise Linux. And funny thing is that if you Google for distroless, you will certainly find a blog post from Red Hat bashing against Google distroless. And you read it and you think like, okay, maybe it's not the best, but if you read it until the end, it's just an advertising for Red Hat UBI Micro. So then there's Ubuntu Chisel. It's pretty new from 23 and highly inspired by Google distroless. It's open source project by Canonical, the organization behind Ubuntu. And they're also not providing so many production ready images. You also have to build them yourself. But the nice thing here is that you have the Ubuntu policy behind them, making sure that all critical and high severity vulnerabilities are fixed within 24 hours. And finally, we have ChainGuard images. So ChainGuard is a security vendor founded in 21. And the interesting thing here is that they're providing images for all runtimes, even maybe not so popular ones like Ruby or PHP. So, and also they really have zero vulnerabilities for all the runtimes they provide. So we'll present that in a second. But for now, coming to a little live hacking demo, showing you like an example of a vulnerable application and how distroless could prevent these classes of attacks. So let me see if that works. Yeah, I made a movie, so to not blow it up. I got IP addresses. Okay, what you see here, I guess it should be large enough, right? Is a Node.js application, simple application, just starting a listener, accepting an HTTP request on the root, and if there's no query parameter, it just sends an HTTP response, no query parameter provided. But if there's one, it will directly execute a system command with the input of the query parameter, which is of course a very bad example, but there are more complex implementations coming down to exact this issue, right? So just to demonstrate, and it will send the standard out of the system command back as HTTP response. So we want to check, I already built it, simple Docker file. It's based on Node version 16 Debian Bullseye, and it just basically copies over the source and installs its dependencies, exposing the port and run it. So let us try to run it. You can see in the bottom. And now it should be up, and I want to test it with curl. So let's just fire a simple HTTP request without any query parameter. Okay, application is up and running. So let's try some, and as we know, it executes a system command. Let's try some shell command like list directory. And at that point, I guess you already get the point. We get directory contents from inside the container from the outside. But I want to present a little more sophisticated example. So there's a remote machine. I have a netcat listener on a port 4445, and I want to exploit the application now with getting a reverse shell against that machine. So, and as netcat is inside that Node 16 image, I'm lucky. And so the payload will be a little bit more complex, and I blurred out the IP address, but basically it connects against the IP of my remote machine with the port 4445, injecting bin bash to get the reverse shell connection. And if you fire that HTTP request, you will see that no response is coming back. So line 14 here in the code will now connect via netcat to the remote server. We get the connection in that machine, and now we can, of course, try if it's working. And we got a reverse shell here. So who am I? We even root. So you see, from the outside, we got a shell connection inside of the container. And as it's root, like maybe you know it with Docker, if you build an image, it's unfortunately defaultly built as root. And the root inside of the container is the same PID as on your host. So which is a real issue with, that's why it's the best practice to always build explicitly as user. declarations to a Docker file to not build it as root, so we can do a lot of enumeration here. Like as we are root, we can install stuff. I guess you get the point. So now we just want to show how dist2less could prevent these kind of attacks in a very simple way. Let's have a look at our Docker file. And in Docker, you have a concept of multi-stage builds. And in the second stage, as you can see here, we're just switching to the Google dist2less base image for Node.js version 16 and copy everything over, basically. And then we expose the same port and run it. So first I need to remove the old machine, and now I'm going to build it again. And as you can see already, it's fetching from Google Cloud Registry. Build is done. Let's run it. And test it with curl again. So let's test our list directory. It's not working anymore. Okay, let's test our. So the application itself is running fine, which is quite important. Yeah, just it's running with dist2less. And let's try our more complex payload again, and it's not working. HTTP response is coming back directly, and we don't get any connection on the remote server. And of course, we want to see why is that. So let's quickly have a look at the logs. We just need to find the ID of the container, and now we can have a look at the logs. And I just have to blur out the IP, but in the top here, you can see that it throws an error that there's no shell. So basically, that's the solution. And also for the end, if we had scanned this with Trivi, which is an open source container image scanner, we would have, for the old image, we would have 238 public vulnerabilities, of which are 221 high and 17 critical. So imagine the team coming to us like, how should we fix that? And if management dictates you are not allowed to deploy to production with that. So after you switch to dist2less, you only have 2, of which 2 high. So pretty nice outcome, I would say. Okay, then coming back to the demo. We also think that it's a good idea to have scientific proof for what we say. And with Secure.io, we have a long-running collaboration with the University of Applied Sciences in Augsburg. And lately we joined a little research project on container security. And we wanted to have a look at 3 questions here. First, we want to see if these component reduction methods really drastically remove the noise of container scan findings. Also, we want to see if typical findings are actually exploitable, like exploitation probability. And also, third, we want to see some implications when integrating these methods into the development lifecycle. And we are in the middle of the research, but I can present already a little bit of the results. So, for example, we scanned like 20 images or so, all from the presented methods I showed you. And as you can see, for example, if we have a look at the chain guard images or the dist2less images, or for example, the UBI micro ones for Java, they all have like 0 findings, really, really 0. This is also the thing they advertise with, for example, chain guard. Yeah. So this looks good for research question 1. And for the second, we looked at, in total, we found 563 CVEs. And besides the CSVS score, which is typically used for remediating vulnerabilities for critical and high, there's also from the first organization the EPSS, which is the exploitation probability scoring system, and we checked that API for all of the CVEs we got, and we see that only one has. And what the score says is that it's the exploitation probability within the next 30 days, and they taking much more sources into account, like Metasploit, ExploitDB, GitHub adversary database, and much more to calculate the score. There's a nice paper explaining it, and we only see one CVE with a probability of 38, one with around 9, and all the others of 500 are like under 5%, which is pretty interesting. So regarding, at least according to that score, exploitation probabilities pretty low for most of the findings. So I hope you feel like that after you deploy the dist2less image. Coming to the advantages, like we get minimal images only containing the runtime and the application and its dependencies. No shells, no package managers, no no other stuff, maybe no netcat binary, which your application doesn't need anyway, and therefore reduced attack surface and less findings of container scanners. Also it removes entire classes of attacks, like I showed in the demo. And of course, the side advantage here is that you get faster transfer times and less storage size, which also leads to less costs, which also is a nice business case. You can argument when you want to integrate that. And we get faster build times, which is also always a good thing regarding DevSecOps. And coming to the disadvantages, or rather challenges. So we have complexity and compatibility issues. So let me give you a quick example. So we recommended Distoless for a Node.js application, and they tried it, and they got a runtime exceptions coming back to us and say like, hey, security team, this is not working. And then we had a look at the application and saw that they are dependent on a Kafka library, which is in turn a wrapper for a C++ library, which has the dependency on a compression shared object binary lying around in a normal Linux distribution, which was not lying around in Google Distoless distro. And after some fiddling around with LDD, we get the dependencies, and we found out that you can just install in the first stage the shared objects you need, and you copy them over in the second stage, which is which seems to be the accepted solution. And the thing is just, this is a little bit complex, and that's why you need really good understanding about the underlying systems, kernel features, Linux distributions, and that stuff. But it's always a good idea, and we learn stuff. So there's this debugging issue. For example, if you don't have a shell, you can imagine sometimes you need a shell to debug stuff. Google Distoless, you don't have a shell. But they're providing debug images, so there's a simple solution within your dev environment. You just build them with the shell, and for production, you have another pipeline which build it without shell. And no support for certain runtimes, at least for Google Distoless, but so if you need PHP or Ruby or something, then you should rather go for JGuard. So coming to the conclusion, just want to say one more time that teams are responsible for the selection of the base images. So this saying it's not our code is just not really working. And Distoless methods do make your applications more secure, even scientifically proven. So if you can, dig into and use them. And some final recommendations. So as a final recommendation, we would say use Google Distoless if you can, or JGuard. That would be the first we would recommend you to have a look at, or even Alpine if you can, but it depends on the C library you need. Scan your images and fail your build. We say that always, and don't build your image as root, because our scanners, we have just 90% of compliance checks. Don't build your image as root. Yeah. And finally, if you want to integrate these Distoless concepts, we made good experience with creating a community approach around it. So if you have multiple teams integrating and you have these issues, like I said, with the Kafka library, it's a good idea that if someone solves it, the other ones should not solve it again, so to share knowledge. And yeah, at this point, I'm at the end, accepting questions, and thanks so much for listening. Yeah.
First question.
Thank you so much for the presentation. Clearly, you're making it so hard for hackers to, live off the land. Basically, there's no land. But still, do you think it's practical that for some, let's say, developers or companies, they're building a complex application, distributed, that need to be maintained with add features and whatsoever, with minimal images, it's going to be super hard for them to, add features. That leads into this being maybe impractical for some applications, right?
So how would you say that adding features would be, or like Distoless would blocking adding new features?
No, I mean for example, they build an application, and after a while they need to add some features, meaning some libraries, dependencies, packages. Mm-hmm. That means that the maintainer of the image, every time they have to go and add this package, for example, manually, and that leads to, people being so busy maintaining the package itself.
Yeah. But you're talking more about that features lying around in a Linux distribution, because the normal features and dependencies you're adding to a project, like think about Java. In Java, you have Maven and the POM XML defining your external dependencies, right? So adding new features, coding, adding new dependencies to your POM XML from Maven, and then you just build it in your pipeline using Google Distillers as a base and deploy it. So not with every new feature, I would say, you need a new dependency. So it could be possible, yeah. It could be possible, but I would say it's rarely the case. That was just a special case.
What I meant is, at some point, the developers would start adding packages or libraries, for example, that lead to more attack surface, and they may give up at the end and like, let's add a shell because we want to debug something. And, you know, so is this practical? Do you think? Have you seen cases where, on the long run, people saying, right, this is perfect, this is a good solution?
To be honest, developer motivation integrating this is quite low to our experience, yeah. Because like of these complexity topics, when we showed them like this Kafka, okay, this Node.js application is running it in production. But yeah, if I see it practical, from a security point of view, of course, yeah. But that's maybe always the issue. How do you bring these guys into using it, yeah?
Yeah, I would add to that. I mean, normally adding new features and modifying the application itself, I think that is not the issue. Yeah? You deploy new features all the time, and ideally you have a CI/CD pipeline that can run multiple times a day to give you new features and patches and so on. What might be a hurdle, or what we got as feedback, is that developers need to build their own images basically, and so they need to maintain the Docker scripts and everything, and that might be a bit less inconvenient for them than using predefined images from Node.js or whatever. And so that was one of the feedbacks I think that we got. But on the other hand, it is always like if you build your own images and you know what source you're building from, you have way better control of what's inside these images. So there has been other research, not done by us, but by colleagues basically showing that even in Node.js images, you might have a curl that is precompiled and loaded into this image, and as a security, you have no clue where that comes from. But if you start with your clean images, then you have way better control of what's in there. So that is a bit overhead, but it's recommended to do it that way anyhow.
Thank you.
I was just trying to open the Pepsi, but I couldn't make it.
Hey, yeah, thanks for the talk. Very interesting. So I have a question. You mentioned one of the disadvantages is that, like debugging, that you're less flexible when doing debugging. For example, on prod, I mean, something's not working. Maybe connection to some upstream server isn't working on prod, but on all your other stages could happen. What would you recommend to teams like adopting or trying to adopt this approach where, for example, you don't have a shell or like common debugging tools installed? Is there a way to still be able to then debug on those production images, or do you need to then like switch to a different kind of debugging image deployed in your Kubernetes cluster and then like, you know, try to reproduce the same issues that you have in prod on this container?
So yeah, to be honest, like we never had the case that you really have that issue what you just described, that you have to get into the shell of your production image. So, and we're recommending it from a security perspective and did some research on it, but we have not so much experience that we can recommend all the use cases. I guess that would be more like for developers integrating it, and then you come to the point and you find a solution. So, but at the point currently, I don't have any solution. What one team, of course, is doing is capturing the logs, like in Elk or something. But you don't really can. But the ChainGuard images, they have a shell. Mm-hmm. Yeah, at least you have the decision if you want it or not. So. Yeah, and you could, if you be concerned about that class of attack, which I just showed in the demo, you can also integrate cloud workload protection and preventing unwanted shell execution or some behavior in production. So then this way you could debug your image in prod. Yeah.
Okay, we have time for, I guess, one last question.
Just a reflection in terms of implementation, because everything that is orchestration and cloud computing has many hidden costs that probably an engineer is not aware of. Basically, patching, secure configuration in Kubernetes, etc. They are not aware. Basically, they are people that they are good at writing code, but they are not infrastructure people. And if we propose a solution like distroless, the concept, they only see the cost of implementation, but they don't see the hidden cost of vulnerabilities, because unless they are asked by policy that they have to fix the vulnerabilities before they go live, etc., they don't see the cost. For them, implementing distroless is extra work that is not there if we don't ask, because they just download something from Docker Hub. So probably before trying to make this kind of implementation, we need to have a conversation with the engineering team so they understand the pros and cons and what we are trying to solve in the first place. Otherwise, based on personal experience, they will not buy the project.
Yeah, I mean that's always a good point, now that you need a business case for security in a way to make sure why it's worthwhile your time. But I mean, if you're really struggling with high number of vulnerabilities in images like we did, yeah, then you have the developer pain anyhow. So then they are very grateful for any way to solve this, or any approach that you can solve it. And then in the long run, instead of dealing and assessing all, because what you do, if you cannot go for something like distroless, then you have to go into details, and you have to security people sit there and assess the individual vulnerabilities, at least the critical ones, and look into it and decide at some point, can we go live with this? Is this something we can ignore, or is this something that's really critical? And this is, I think, the hidden cost that you're also mentioning, because then you have people spending time with it. You pay your security team, and those are expensive people usually, for looking into it. And if you can solve it in a more technical way, like solve it once, implement a pipeline, and then you have less headaches and have less cost to spend on people to fix it or assess it, then that's also some kind of business case you could construct there.
Okay, so we are at the end. I noticed there are still some questions. I guess Michael would be happy to take them in the breaks. So thank you very much for the interesting topic.
Thank you too.
Yeah.
Thank you, everyone.